Hello, 30-1s. Welcome to your next unit, Trigonometry. Before we fully get into the unit, what I want to do is I want to do a quick video to introduce you to why we're working with trigonometry in the way that we do. Now, will any history of trigonometry questions show up on my test? No, not explicitly, but if you follow along, it's going to help you make, I think, a lot of sense of what we're doing and, more importantly, why we're doing it. So, the history of trigonometry, summed up in 5 minutes. So, what's happening here? We like to think of trigonometry as this, as our favorite formula of all time, Pythagorean, a squared plus b squared equals c squared. And we like to think of trigonometry as, oh, it's this, right? Here's a right triangle. I'm good to go. And our good old friend from earlier, SOHCAHTOA, and all that stuff. Well, what I'm here to tell you is, yeah, that's how we look at trigonometry now, but that's not where trigonometry came from at all. So where did trigonometry come from? Well, like all math, it comes from nature, and it comes from humans trying to model and predict things that are happening in nature. I don't see a lot of right triangles flying around in nature. Well, so where does this come from? We're going to go back in time several thousand years to ancient Babylonia, which is now somewhere in the Middle East. Present-day Iraq is where the Babylonians would have been. And, if we're looking up in a history textbook, the Babylonians are probably most well known for the ancient wonders of the world, the hanging gardens and all this. But what I want us to think about is this. What the Babylonians were concerned about, or some of them at least, was looking up to the heavens. And so there's a nice little scientist, and she's looking up to the heavens, and she says, geez, I wonder how far away that star is, right? She's looking at the sun. How far away is the sun? That's a pretty big question, given that they don't have Google and that their biggest piece of technology is probably a stick and maybe some steel, right? This is a big question to ask. So where does she start in her journey here? Well, she says this. She says, hey, I know the sun rises in the east and it sets in the west. So the sun is going to come up over the horizon. It's going to come down like this, and it's going to come all the way around. Well, do you see here? That's our quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if you've ever wondered why the quadrants go in that direction, now you know. We're following the sun. So she's looking up at the sun saying, okay, how far away is that? That's a big question to ask. So they come up with this great estimation, first off, of how many days does it take for the sun to go around us? How many days? Well, again, given their limited technology, they come up with approximately 360 days. Now, we believe that they know they were not quite right, but they end up sticking with 360. They also had a geocentric model of the universe. So they thought, of course, the sun went around us. Okay, we know that's wrong too, but that's okay. So 360 becomes this all-important number. And they thought the sun would go around us in a circle. So now circles become this big mythical shape, right? It has to be really important. So we know now it's 365 days, and we know that we go around the sun, and it goes around in 365.25 days in an oval or an ellipse, right? But this is actually where trig starts. They think it's a circle. Okay, so now what I'm hoping you have maybe noticed is they say, okay, look, it takes 360 days. So that's important. How many degrees are in a circle? 360. And there you go. There's where degrees come from. Degrees are human made. They're not scientific. And that's going to be really important very shortly. Okay, so let's go back to our scientist here. So she's looking up at the heavens and she's saying, how far away is the sun? Well, she's really brilliant. And she says, I'm never going to be able to figure out this distance, but I need to call it something. So she's really brilliant. She says, I'm going to say it's 1 astronomical unit away. I don't know how far away it is, so I'm going to call it 1 because 1's a really easy number to work with. We still use that today. The distance from Earth to the sun is 1 astronomical unit. Super cool. So then she says, okay, I don't know. I'm never going to figure out that actual length, but I'll call it 1 astronomical unit. She says, okay, wait a minute. I can't measure that height right there. I can't measure that height. But what I could do, if I really could think about it, is if I walked over, if I could somehow say, look at that star, that sun is right over there on the horizon. I could, however, walk over this way, couldn't I? I could figure out that distance. Yeah. And right here, guess what? That meets at a 90-degree triangle. What do we have? Well, we've got Pythagorean before Pythagoras was even alive. Okay, now let's switch these variables up just slightly. That is the height, so I want you to think that is the height of the star. Let's call that y. That's what we're used to calling it, isn't it? And what I want to think about here is our hypotenuse. Well, we've got a circle. We've got a circle. So maybe instead of calling this the hypotenuse, it's a circle. So instead of the hypotenuse, we're going to call this the radius. And let's continue on. We do know a squared plus b squared equals c squared. But let's put it in terms of what we're working with. Well, in terms of the Babylonians in trigonometry, this is now x squared plus y squared is equal to r squared. Okay, that's the equation of that triangle, but guess what? That's the equation of our circle as well, centered at the origin. But that's the equation of a circle. Cool. Okay, so what I'm trying to get at here is trigonometry has its basis in circles. That's what makes circles so important. The triangles end up being a way for us to work with the circles. Isn't that neat? Okay, so the scientist is up here and she's trying to figure out all of these complex questions. And another big question that we need to answer is, how far has that traveled? So we call that theta now, right? How far has that star traveled? Okay, well, how far has the star traveled? Well, now we're talking about this distance. How far has the star traveled? Well, this is going to be known as our arc. Simple as that. So let's think about this. Trigonometry is really about helping us solve circles. And the arc is how far our sun or our star has traveled as we've been watching it. That's it. Those are our two big questions for the moment. So the problem that we're about to face here in your first, let's call it real lesson, is this. I'm just going to sketch this again. Is that degrees are human made. And we don't like that. Like if we think of imperial measure and we start thinking of feet and inches, we don't like those because they're complicated to convert between. And they're also based on the king's foot, right? We don't need that stuff. We want scientific measure. So what we need to do is we need to do away with degrees. And we're going to move to a new unit of measurement called a radian. So here's how this works. We're going to get rid of degrees right here. So degrees, by the time you're done begin calculus, degrees will be no longer. We need to move to something called a radian. Right? And if you've reset your calculator before, it's always in radian mode. And now you're about to see why. So here we go again. Here's our star up on the horizon. What we want to ask is how far has this star moved from rising in the east? Okay, well, what we're going to say, what the Babylonians were so brilliant in saying is this. This is called our arc. And they were so brilliant in this. They said, we need a good way to measure this angle. So we're going to say this is 1 astronomical unit. That's our radius. A radian is the measure when the arc is equal to the length of the radius. So that is, the arc is also 1 astronomical unit away. That's it, my friends. That is what a radian is. A radian is simply a measure of our angle, is theta, so the central angle. Radian is the measure of our central angle when the radius and the arc are both 1. That's it. That's what a radian is. So we want to get away from thinking of this in degrees. We want to start thinking about this in terms of radians. Well, if I can write this angle in degrees, guess what? I'm going to be able to write it in radians. So that's what our next lesson is going to be. Our next lesson is going to be about how do I convert between what I know, degrees, into radians. Well, if I can convert from feet to meters, then you'll be able to convert from degrees to radians. Okay, that is your history of trigonometry. I hope you found it as cool as this nerd does. And the next lesson will be converting from degrees to radians.